All right, let's get to the first feature, which is reading and writing documents. In this case, we are taking the inverse approach. Usually we start from the client, which sends a message to a load balancer, which then sends it to the correct service. And then finally, the database is kind of ignored. In this case, the database is extremely important because there's a lot of documents which are going to be stored. Let's talk about how we are going to be storing these documents. Firstly, we need an ID for a document. We also need the author or the creator of this document. And we need possibly people who are collaborating in this document, but that can be taken care of separately during permissions, okay, while you give permissions. So the document just has an ID, an author, and the data. So this contains all the characters in the document. The type of this will be text, okay. The author is going to be a varchar or just basically a small text field. And the ID is going to be randomly generated. It's a primary key. Apart from this, you'll also have something like creation timestamp and metadata around the document. So this is a very common pattern where you have a lot of data that has to be stored and a lot of metadata for that document or for that image or for a profile. What ends up happening is it's better if you're able to take all this metadata information and store it in one table to a corresponding ID. So there's ID, there is the creator or the author, there is the timestamp, and all other metadata. So I'm assuming a variable number of columns here. This is one table, which is doc metadata. And the other table, which is doc content, actually stores the document content with a corresponding ID. So there's the ID here and there's content. Content is, like we said, of type text. So this column is over here and the rest of the columns all come here. Now if you need the doc content, all you need to do is query this table. And if you need metadata, which is very useful when you need some sort of relational data, you need to find out how many unique authors have created documents in the last 3 days. So that gives you the unique user count. You can also say how many documents have been created in the last 3 days. So you just need the count of the documents in the last 3 days. Then you just do a SQL query on the count based on timestamps. So something called an RDBMS is going to work here. And this content would be preferably stored in a NoSQL database. There's also another design that you can use. You can just store the ID and all of the data to that corresponding ID in a single table. In data, you'll have JSON objects. They'll have keys of author is, let's say, GKCS, comma, the next field, which is timestamp. So timestamp is 123, comma, so on and so forth till you have data. So all the metadata has key value pairs, and finally the data itself is a key value pair, which has all this stuff inside it. Okay, so there's basically two ways you can do this. One is to split the metadata and to take the contents, and the other one is to keep them all together. Both have advantages and disadvantages. Why do you want to split the metadata? Well, whenever you need to do some sort of relational querying, you can do this on just this table so that it's small, it's short, it's easier to do those relational queries without the bulky contents being in it. And whenever you need the contents of this doc ID, all you need to do is just do a join on this. And whenever a user sends a request for an ID 123, let's say, you just fetch the contents corresponding to that ID and return it to the user. So this seems like a good idea, separating concerns and keeping things decoupled and also answering queries quickly. But eventually it turns into a mess. More often than not, what happens is this table has a lot of alter queries. Firstly, the metadata is hard to fix. You're always going to have something or the other that we have forgotten. So there's going to be an alter table query command required that time. And the other problem, which is a much bigger problem, is you're going to have eventually some sort of joins on the NoSQL database and the relational database. For example, let's say that you want to find the last 10 documents that you have created. So this is based on author, right? So you'll get an email ID and you have to query this thing. So based on this author, which are the last 10 IDs that you can pick up? And these IDs have then to be picked up from this table. This is a real nightmare because even if you do a join on NoSQL tables, like two NoSQL tables, it's slow. NoSQL is not designed for joins. RDBMS is kind of designed for joins. But if you're doing a join on a NoSQL and a relational database, it's going to take forever. Okay, it's not even in the same database, these two guys. So we are not going to be taking this approach. We are instead going to be taking this approach, that all the data is dumped into the data column for a corresponding ID. If there is ID 123, it has this stuff. If there's ID 234, then a new entry is made with the author, timestamp, and all other metadata plus the contents of the file being stored in this column of data.